Integrate the rational function x upon x plus 1 into x plus 2 dx, and we can see that the rational function whose numerator degree or degree of numerator is equal to 1 and degree of denominator is 2, so that we can say this is a proper fraction. One is less than 2, so we can say it is a proper fraction, and x plus 1 and x plus 2 are the linear factors, so we can write which is equal to, or let me write here, x upon x plus 1 into x plus 2, we can write it as a upon x plus 1 plus b upon x plus 2, so that x is equal to a times of x plus 2 plus b times of x plus 1, and the denominator x plus 1 into x plus 2 gets cancelled, so that x is equal to a plus b of x plus 2a plus b. Comparing the coefficients, coefficient of x is 1, so we can write a plus b is equal to 1, and the constant 2a plus b is equal to 0. So solving these both equations, so we'll get 2a minus a is equal to 0 minus 1, that is minus 1. So a is equal to minus 1, and substituting a is equal to minus 1 here, you will get b is equal to 2. So a is equal to 1 and a is equal to minus 1 and b is equal to 2, and hence we can write the integral x upon x plus 1 into x plus 2 dx is equal to a value is minus 1 upon x plus 1 plus 2 upon x plus 2 integral dx, or we can write integral minus 1 upon x plus 1 dx plus integral 2 upon x plus 2 dx. Integration of 1 upon x plus 1, since the coefficient of x is 1, so we can take directly minus log mod of x plus 1 plus again 2 upon x plus 2, we can write 2 times log mod of x plus 2 plus c, or we can write log of x plus 1 whole to the power minus 1 plus log x plus 2 whole square plus c, or we can write log x plus 2 whole square upon x plus 1 plus c. So we can give the answer log of x plus 2 whole square upon x plus 1 or mod of x plus 1 plus c is the final answer. Integrate the rational function 1 upon x square minus 9 dx, and here which is in the form of x square minus 3 square dx. We know that integral 1 upon x square minus a square dx is equal to 1 upon 2a log of x minus a upon x plus a plus c. So we can write which is equal to 1 by 2 times of 3 log mod of x minus a, that is x minus 3 upon x plus 3 plus c, that is 1 by 6 times log mod of x minus 3 upon x plus 3 plus c is the answer. Integrate the rational function 3x minus 1 upon x minus 1 into x minus 2 into x minus 3 dx. So here if we consider the fraction or rational function 3x minus 1 upon x minus 1 into x minus 2 into x minus 3, we can say that the degree of numerator is 1 and degree of denominator is equal to 3. So 1 is smaller than 3. So we can say that it is a proper fraction. So that we can Express this rational function as 3x minus 1 upon x minus 1 into x minus 2 into x minus 3 is equal to a upon x minus 1 plus b upon x minus 2 plus c upon x minus 3, that is 3x minus 1 is equal to a times of x minus 2 into x minus 3 plus b times of x minus 1 into x minus 3 plus c times of x minus 1 into x minus 2. Now to get the constants a, b and c, let us substitute. Put x is equal to put x is equal to 1, so that the left side 3 into 1 minus 1 is equal to a times of 1 minus 2 is minus 1, 1 minus 3 is minus 2, and the remaining terms b times of 0 plus c times of 0. So which implies 2a is equal to 2. So which implies a is equal to 1. And now by substituting x is equal to 2, we have 3 times 2 minus 1 is equal to a times 0 plus b times of 2 minus 1 1, 2 minus 3 minus 1 plus c times of 0, which implies 3 to the 6 minus 1 5 is equal to minus b. So which implies b is equal to minus 5. And then again substituting, put x is equal to 3, you will get 3 times of 3 minus 1 is equal to a times 0 plus b times 0 plus c times 3 minus 1 is 2 and 3 minus 2 is 1. So which implies 2c is equal to 3 3s are 9 minus 1 8. So c is equal to 4. So we got the constants a, b and c, and hence we can write the integral 3x minus 1 upon x minus 1 into x minus 2 into x minus 3 dx. We can write it as a, that is integral 1 upon x minus 1 dx, and b is minus 5, so minus 5 times integral 1 upon x minus 2 dx, and c is equal to 4 times integral 1 upon x minus 3 dx, which is equal to log mod of x minus 1 minus 5 times log mod of x minus 2 plus 4 times log mod of x minus 3 plus c is the answer. Integrate the rational function x upon x minus 1 into x minus 2 into x minus 3 dx, and you can see that the numerator degree of numerator is equal to 1 and degree of denominator is 3. So 1 is smaller than 3, so we can say that degree of numerator is smaller than degree of denominator, which is a proper fraction. So we can split up the rational function as, or we can resolve into x upon x minus 1 into x minus 2 into x minus 3 is equal to a upon x minus 1 b upon x minus 2 plus c upon x minus 3, since they are linear factors. And then we can write x is equal to a times of x minus 2 into x minus 3 plus b times of x minus 1 into x minus 3 plus c times of x minus 1 into x minus 2. Now to get the constants a, b and c, so let us substitute or put x is equal to 1, which implies 1 is equal to a times of 1 minus 2 minus 1, 1 minus 3 minus 2 plus b times of 1 minus 1 0 and c times of 1 minus 1 0. So which implies 2a is equal to 1, that is a is equal to 1 by 2. And now put x is equal to 2. So we have 2 is equal to a times of 0 plus b times of 2 minus 1 2 minus 1 1, 2 minus 3 minus 1 plus c times of 0 is equal to, or we can write minus b is equal to 2. So that is b is equal to minus 2. And then put x is equal to 3, so that we have 3 is equal to a times of 0 plus b times of 3 minus 3 0 plus c times of 3 minus 1 is 2 and 3 minus 2 is 1, so that 2c is equal to 3. So c is equal to 1 upon 3 upon 2. So our integral we can write it as integral x upon x minus 1 into x minus 2 into x minus 3 dx is equal to integral of a value is 1 by 2, so 1 upon 2 times of x minus 1 dx, and b is equal to minus 2 times of 1 upon x minus 2 dx, and c is 3 upon 2 times integral 1 upon x minus 3 dx, which is equal to 1 by 2 log mod of x minus 1 minus 2 times of log mod of x minus 2 plus 3 upon 2 times log mod of x minus 3 plus c is the answer. Integrate the rational function 2x upon x square plus 3x plus 2. And here we can also write 2x upon x square plus 3x plus 2 is, we can factorize it to x plus 1 into x plus 2. And hence we can say a degree of the numerator is 1 and degree of the denominator is 2. So it is a proper fraction. So that we can resolve into factors as 2x upon 2x upon x plus 1 into x plus 2 is equal to, we can express this as a partial fractions as a upon x plus 1 plus b upon x plus 2. 2x is equal to a times of x plus 2 plus b times of x plus 1. So that is 2x is equal to a plus b of x plus 2a plus b. Now comparing a plus b is equal to 2 and 2a plus b is equal to 0. Solving this both, 2a minus a is equal to minus 2. So that is a is equal to minus 2, and substituting a is equal to minus 2. So we'll get minus 2 plus b is equal to 2. So b is equal to 4. So that we can write integral 2x upon x plus 1 into x plus 2 dx is equal to integral of a is minus 2 upon x plus 1 plus 4 upon x plus 2 dx. So which is equal to minus 2 log mod of x plus 1 plus 4 times of log mod of x plus 2 plus c is the answer. Integrate the rational function 1 minus x square upon x times of 1 minus 2x dx, and here we can say that the degree of numerator is equal to 2 and degree of denominator is also equals to 2, both are equal, so that it is said to be an improper fraction. So we cannot resolve into partial fractions directly, so we need to first divide 1 minus x square, or we can write minus x square plus 1 divided with here x into 1 x minus 2x square, so minus 2x square plus x. So we can write minus 2x square 1 upon 2 times, so minus x square plus x into 1 by 2 is x upon 2, and then we can say 1 minus x upon 2 is the remainder, and so we can write 1 minus x square upon x times of 1 minus 2x is equal to 1 by 2 plus 1 minus x upon 2 divided by minus x square plus 1, or we can write x times of 1 minus 2x. So let us simplify first. 1 minus x upon 2 divided by x times of 1 minus 2x is a proper fraction, and it can be resolved into a upon x plus b upon 1 minus 2x. So we can write 1 minus x upon 2 is equal to a times of 1 minus 2x plus b times of x. So the coefficient of, we can write 1 minus x upon 2 is equal to a minus 2a plus b of x. So comparing the coefficients here, minus 1 by 2 are the constant a is equal to 1, and minus 2a plus b is equal to minus 1 by 2. Substituting a is equal to 1, minus 2 plus b is equal to minus half, or b is equal to 2 minus half, that is b is equal to 4 minus 1, that is 3 by 2. So we can write the integral now. Integration 1 minus x square upon x times of 1 minus 2x dx is equal to, so 1 by 2 times integral 1 by 2 dx, plus again we can write this as a upon a is equal to 1 upon x, and again the next b is equal to 3 by 2. So we can write 3 upon 2 times of integral 1 by 1 minus 2x dx. So integration of 1 upon 2 dx is x, and integration 1 upon x is log mod x, and here plus 3 upon 2 times of integration is integration 1 upon 1 minus 2x, since the coefficient of x is negative 2. So we can write log mod of 1 minus 2x and divided with minus 2 plus c, or we can give the answer finally as x plus log mod x minus 3 upon 4 log mod of 1 minus 2x plus c is the answer. Integrate the rational function x upon x square plus 1 into x minus 1 dx. So here we can say that the degree of numerator is 1 and degree of denominator is 3. So we can say this is a proper fraction, and hence we can resolve into partial fractions. And moreover, x square plus 1 is an irreducible factor here. We cannot factorize it further, and hence we can write x upon x square plus 1 into x minus 1, we can write it as ax plus b upon x square plus 1 plus c upon x minus 1, or x is equal to ax plus b times x minus 1 plus c times of x square plus 1. So x is equal to ax of x minus 1 plus b times of x minus 1 plus cx square plus c, or x is equal to ax square plus cx square minus a plus b of x, and again the constant is c minus b. Now comparing the coefficients on both the sides, we get coefficient of x square is 0, so a plus c is equal to 0. Coefficient of x is 1, so minus a plus b is equal to 1, and constant term is 0, so we can write c minus b is equal to 0. Adding all these three equations, we get 2c is equal to 1, that is c is equal to 1 by 2, and from the third equation c is equal to b, so we can write b is also equal to 1 by 2, and from the second equation minus a plus 1 by 2 is equal to 1, or we can write a is equal to minus 1 by 2, so that we can express integral x upon x square plus 1 into x minus 1 dx is equal to minus 1 by 2 x plus 1 by 2 upon x square plus 1 dx, and c value is 1 by 2, so 1 by 2 times integral 1 upon x minus 1 dx, which is equal to minus 1 by 2 times integral x upon x square plus 1 dx plus 1 by 2 times integral 1 upon x square plus 1 dx plus 1 by 2 log mod of x minus 1 plus c. Or we can add 1 upon 2 times. Here multiply and divide with 2. So we can add 1 by minus 1 by 4 times. We can see very clearly that differentiating the denominator is the numerator one. So if we substitute x square plus 1 as t, so we have 2x dx is equal to dt. So we can write the integral dt divided by t and plus 1 by 2 log mod of sorry, integration of 1 upon x square plus 1 is tan inverse of x plus 1 by 2 log mod of x minus 1 plus c, that is minus 1 by 4 log mod t is nothing but x square plus 1 we can write, plus 1 by 2 tan inverse of x plus 1 by 2 log mod of x minus 1 plus c is the answer. Integrate the rational function x upon x minus 1 whole square into x plus 2 dx, and here we can say that the degree is of numerator is 1 and degree of the denominator is equal to 3, so it is a proper fraction. So we can resolve into partial fractions, and moreover there is a repeated root x minus 1 whole square, and hence we can write x upon x minus 1 whole square into x plus 2 is equal to a upon x minus 1 and b upon x minus 1 whole square plus c upon x minus 2. So we can write x is equal to a times of x minus 1 into x plus 2 plus b times of x plus 2 plus c times of x minus 1 whole square. So put x is equal to 1. So we get 1 is equal to first term will become 0 and the last term will become 0. So we have b times of 1 plus 2, that is 3. So b is equal to 1 by 3. And now again substituting, or put x is equal to minus 2. So we can write minus 2 is equal to a times of minus 2 plus 2 is 0, and again b times of minus 2 plus 2 is 0 plus c times of minus 2 minus 1 is minus 3 whole square. So we can write minus 2 is equal to 9c, or c is equal to minus 2 upon 9. And then, and now we just let us compare the coefficient of x square. So we can get 0 is equal to here a into x, that is ax square, and again next we'll be getting cx square. So a plus c is equal to 0, that is a is equal to negative c, that is 2 upon 9. So we got a value is 2 upon 9, b value is 1 upon 3, c value is minus 2 upon 9, and hence we can write the integration x upon x minus 1 whole square into x plus 2 dx is equal to a upon, that is 2 by 9 times of integral 1 upon x minus 1 dx plus b times of, that is 1 upon 3 times integral 1 minus 1 upon x minus 1 whole square dx, and minus 2 upon 9 times integral 1 upon x plus 2 dx. So which is equal to 2 upon 9 times log mod of x minus 1, and here we can write 1 upon 3 times of x minus 1 whole to the power minus 2 plus 1 divided by minus 2 plus 1, and again here minus 2 upon 9 times of log mod of x plus 2, or we can also write 2 upon 9 times log mod of x minus 1 plus 2 upon 9 times log 1 upon x plus 2, and again here minus 1 by 3 x minus 1 whole to the power minus 1, or we can write 2 upon 9 times log mod of x minus 1 divided by x plus 2 minus 1 upon 3 times of x minus 1 plus c is the answer. Integrate the rational function 3x plus 5 upon x power 3 minus x square minus x plus 1 dx, and here we can say that the degree of numerator is 1 and degree of denominator is 3. So this is a proper fraction, and every proper fraction we can resolve into the partial fractions. But before that, let us factorize the denominator. X power 3 minus x square minus x plus 1. So we can take x square common. We can get x minus 1 minus 1 of x minus 1, or x minus 1 is taken common, x square minus 1, or we can also write x square minus 1 is x minus 1 into x plus 1. So which is equal to x minus 1 whole square into x plus 1. Linear factors and repeated factors are there. So let us write the rational function can be written as 3x plus 5 upon x minus 1 whole square into x plus 1 is equal to a upon x minus 1 plus b upon x minus 1 whole square plus c upon x plus 1, so that 3x plus 5 is equal to a times of x minus 1 into x plus 1 by taking LCM, and b is equal to x plus 1 b times of x plus 1 plus c times of x minus 1 whole square. To get the constants a, b and c, so let us substitute or put x is equal to 0. So we get 3 times of 0 plus 5, 5 is equal to a times of minus 1 into plus 1 plus b times of 0 plus 1, 1 plus c times of minus 1 whole square, which implies minus a plus b plus c is equal to 5. And now substitute or put x is equal to plus 1. So we get 3 times of 1 plus 5, that is 8 is equal to 8 times of 0 plus b times of 1 plus 1, that is 2 plus c times of 0, which implies 2b is equal to 8, that is b is equal to 4. And now substitute, put x is equal to minus 1. So we get 3 times of minus 1 minus 3 plus 5, that is 2 is equal to a times of 0 and plus b times of 0 plus c times of minus 1 that is minus 2 whole square, that is 4 times c is equal to 2, that is c is equal to 1 by 2. Now substitute b is equal to 4 and c is equal to 1 by 2 in the first equation. So we get minus a plus 4 plus half is equal to 5, or we can write a is equal to 4 plus half minus 5, that is minus half. So the value of a is minus 1 by 2, and hence the rational function or integral we can write 3x plus 5 upon x minus 1 whole square into x plus 1 dx is equal to integration of first term is a, we can write minus 1 by 2, 1 upon x minus 1. Next b term is 4, 4 upon integral 4 times of 1 upon x minus 1 whole square plus c is equal to 1 by 2. So 1 by 2 times 1 upon x plus 1 dx, which is equal to minus 1 by 2 log mod of x minus 1 plus 4 times of integration of 1 upon x minus 1 whole square is x minus 1 whole to the power minus 1 by minus 1 plus 1 upon 2 log mod of x plus 1. plus c, and this can also be written as log x minus 1, we can write it as power minus 1, 1 by 2 times, plus log mod of x plus 1 plus minus 4 minus 4 times, or 4 times 1 upon, or 4 upon x minus 1, or this can also be written 1 upon 2 log of x plus 1 by x minus 1 minus 4 upon x minus 1 plus c is the answer. Integrate the rational function 2x minus 3 upon x square minus 1 into 2x plus 3 dx. And here the numerator degree is 1 and denominator degree is 3. So 1 is smaller than 3. So we can say that it is a rational function. It's a proper fraction. And hence we can resolve this into partial fractions. So we can also write x square minus 1 as x plus 1 into x minus 1. So the rational function 2x minus 3 upon x minus 1 into x plus 1 into 2x plus 3 is equal to a upon x minus 1 plus b upon x plus 1 plus c upon 2x plus 3. So that we can write 2x minus 3 is equal to a times of x plus 1 into 2x plus 3 plus b times of x minus 1 into 2x plus 3 plus c times of x minus 1 into x plus 1. So that substituting or put to get the constants a, b and c, put x is equal to, put x is equal to 1, we get the left side 2 times of 1 minus 3 is equal to a times of 1 plus 1 2, 2 ones are 2 plus 3 that is 5 plus b times of that is 0 plus c times 0. So which implies 10a is equal to 2 minus 3 minus 1. So a is equal to minus 1 by 10. And coming to the next one, put x is equal to minus 1, which implies 2 times of minus 1 minus 3 is equal to a times of 0 plus b times of minus 1 minus 1 that is minus 2 into 2 into minus 1 minus 2 plus 3 is 1 plus c times of 0, which implies minus 2b is equal to minus 2 minus 3 that is minus 5. So b is equal to 5 by 2. And coming to the next one, put x is equal to the third factor, we can take 2x plus 3, so minus 3 by 2. So let us substitute minus 3 by 2. So 2 times of minus 3 by 2 minus 3 is equal to a times first term will get 0 and second term also will get 0. Third term c times of x minus 1, that is minus 3 by 2 minus 1 into minus 3 by 2 plus 1. So which implies that minus 3 minus 3 that is minus 6 is equal to, and here we can write minus 5 by 2 into minus 3 plus 2 that is minus 1 by 2 times of c. So c is equal to 6 4s are 24 divided by 5. So 6 4s are 24, 24 upon 5 negative. So that is the value of c. So now substitute integral. Now integral 2x minus 3 upon x minus 1 into x plus 1 into 2x plus 3 dx is equal to a value which is minus 1 by 10 minus 1 by 10 integral 1 upon x minus 1 dx, and b value is 5 by 2, so 5 by 2 times of integral 1 by x plus 1 dx, and c value is minus 24 by 5 integral 1 upon 2x plus 3 dx, which is equal to minus 1 by 10 log mod of x minus 1 and plus 5 by 2 times log mod of x plus 1, and here minus 24 by 5 into log mod of x plus mod 2x plus 3. Since the coefficient of x is 2, it should be divided with 2. So this is 12 upon 5. Plus c is the answer. That is minus 1 by 10 log mod of x minus 1 plus 5 by 2 log mod of x plus 1 minus 12 by 5 times log mod of 2x plus 3 plus c. Integrate the rational function 5x upon x plus 1 into x square minus 4. We can say that the degree of numerator is 1 and degree of denominator is also equals, degree of denominator is 2 plus 1 3, and here 1 is less than 3, so we can say this is a proper fraction. So we can resolve into partial fractions. We can write 5x upon x plus 1 into x square minus 4 is a reducible. We can write it as x plus 2 into x minus 2, which is equal to a upon x plus 1 plus b upon x plus 2 plus c upon x minus 2. So we can write 5x is equal to a times of x plus 2 into x minus 2, that is x square minus 4, or let me write a times of x plus 2 into x minus 2 plus b times of x plus 1 into x minus 2 plus c times of x plus 1 into x plus 2. To get the constants, let us substitute. Put x is equal to plus 2, so that 5 into 2 is equal to a times of, the first term will become 0 because x minus 2 is the factor. So a times 0 plus b times, even the second term x minus 2 is a factor, so we can take here also 0. And third, c times of 2 plus 1 3 and 2 plus 2 4. So we can write 12 times c is equal to 10. So c is equal to 10 of 12, or we can write 5 by 6. And now let us substitute. Put x is equal to minus 2. So we can write 5 times of minus 2 is equal to a times of minus 2 plus 2, which is 0. And here also b times of minus 2 plus 1 is negative 1, and minus 2 is negative 4, plus c times of minus 2 plus 2 is 0. So we can write 4b is equal to minus 10. So b is equal to minus 10 upon 4, that is negative 5 divided by 2. And now put x is equal to, we can write minus 1. So 5 times of minus 1 is equal to a times of minus 1 plus 2 is 1. 1 minus 2 is negative 1, plus b times of, since x is equal to minus 1, so x plus 1 is a factor, so we will get 0. And even the second c terms of it is also 0, which implies minus a is equal to minus 5, which implies a is equal to 5. And now we got the values of ABC, so we can write integral 5x upon x plus 1 into x square minus 4, or x plus 2 into x minus 2 dx. We can write it as a is equal to 5 times of integral 1 upon x plus 1 dx, and b is equal to minus 5 by 2, so we can write minus 5 by 2 times integral 1 upon x plus 2 dx, and c times of that is plus 5 by 6 times integral 1 upon x minus 2 dx, which is equal to 5 times integration of 1 upon x plus 1, since the coefficient of x is 1, so we can write log mod of x plus 1 minus 5 by 2 times log mod of x plus 2 and plus 5 by 6 times of log mod of x minus 2 plus c. Integrate the rational function x power 3 plus x plus 1 upon x square minus 1. Here we can say that degree of numerator is 3 and degree of denominator is 2, which is smaller than numerator degree, and hence we can say that this fraction is a improper fraction. So we cannot resolve improper fractions into partial fractions. First we need to divide it. So let us divide x power 3 plus x plus 1 divided with x square minus 1. So we'll get x times x power 3 minus x, so that we can get 2x plus 1 is the remainder. So here we can write x power 3 plus x plus 1 upon x square minus 1 can be taken as x plus 2x plus 1 upon x square minus 1. Since we know that by remainder theorem, dividend is equal to divisor into quotient plus remainder. So here dividend, that is x power 3 plus x plus 1, we can write it as divisor into quotient plus remainder. So that now here we can see 2x plus 1 upon x square minus 1 is a proper fraction. So here we can write 2x plus 1 upon x square minus 1 can be taken as x plus 1 into x minus 1, which is equal to a upon x plus 1 plus b upon x minus 1. So 2x plus 1 is equal to a times of x minus 1 plus b times of x plus 1. So that to get the constants a and b, put x is equal to 1, so that 2 into 1 plus 1 is equal to a times of 0 plus b times of 2. So that is 2b is equal to 3. So b is equal to 3 by 2. And now to get the value of b, a value, put x is equal to minus 1. So 2 times of minus 1 plus 1 is equal to a times of minus 1 minus 1 minus 2 plus b times of minus 1 plus 1 is 0. So we have minus 2a is equal to minus 2 plus 1 is negative 1. So that is a is equal to 1 by 2. And now we can write integral x power 3 plus x plus 1 upon x square minus 1 dx is equal to, so here integration of x dx, and the remaining partial fractions a is equal to 1 by 2 times integral 1 upon x plus 1 dx, and b value is 3 by 2, so we can write plus 3 by 2 integral 1 upon x minus 1 dx, which is equal to x square upon 2 plus 1 by 2 log mod of x plus 1 plus 3 upon 2 times of log mod of x minus 1 plus c is the answer. Integrate the rational function 2 upon 1 minus x times 1 plus x square. Here we can say that the degree of numerator is 0 and degree of denominator is 2 plus 1, it is 3. So 0 is smaller than 3. So we can say this fraction is proper, and hence we can resolve into partial fractions. So let us write 2 upon 1 minus x times 1 plus x square, and x square plus 1 is an irreducible factor, we cannot factorize it further, which is equal to a upon 1 minus x plus x square plus 1 is irreducible second degree, so we can write bx plus c in the numerator and denominator is 1 plus x square. So 2 is equal to a times of 1 plus x square plus bx plus c times of 1 minus x. To get the constants, first let us put x is equal to 1. So we'll get 2 is equal to a times of 1 plus 1 square, that is bx plus c times 1 minus 1, that is 0. So we can write 2a is equal to 2, which implies a is equal to 1. And next, let us substitute or put x is equal to 0. So we get 2 is equal to a times of 1 plus 0 plus b into 0 plus c times 1 minus 0. So which implies 2 is equal to a is equal to 1. So 1 times of 1 plus 0 is 1 plus c. So we can write c is equal to 2 minus 1 is 1. And to get the constant, another constant b. So let us equate or compare the coefficient of x square on both the sides. So we get 2 is equal to or 0 is equal to, there is no x square term on the left side, so we can write 0 is equal to a times of x square, so a here, and again b is multiplied with minus x, so we'll be getting minus bx square, so minus b. That's all, only two terms are there, a x square and minus bx square. So a minus b is equal to 0. We know a is equal to 1 or a is equal to b, so b is equal to 1. So we got the constants, a is equal to, b is equal to, c is equal to 1. So we can write into partial fractions as integral 2 upon 1 minus x into 1 plus x square dx is equal to, a value is 1 upon 1 minus x integral dx, and again here bx, that is 1 times of x plus c divided by x square plus 1 dx. Or we can write integration 1 upon 1 minus x is log mod of 1 minus x divided by coefficient of x is minus 1, so I write minus 1, plus again here we can write x upon x square plus 1 dx plus integral 1 upon x square plus 1 dx. So let us multiply and divide with 2 here. So by substituting x square plus 1 is equal to t, so we get 2x dx is equal to dt. So our integral can be written as dt upon t, that is log t. So I can write minus log mod of 1 minus x plus 1 by 2. It is nothing but integration dt upon t plus integral of 1 upon x square plus 1 is tan inverse of x. So we can write tan inverse of x plus integral constant c, or this can also be written minus log mod of 1 minus x plus 1 by 2 log mod of t is nothing but x square plus 1 plus tan inverse x plus c. And here since mod of 1 minus x, we can also write minus log of x minus 1 also can be taken, plus 1 by 2 log mod of 1 plus x square plus tan inverse x plus c will be the answer. Integrate the rational function 3x minus 1 upon x plus 2 whole square. Here it is a proper fraction since the numerator degree is 1 and denominator degree is 2. So we can resolve into partial fractions as a upon x plus 2, since it is a repeated factor, so we can write one more b upon x plus 2 whole square, so that 3x minus 1 is equal to a times of x plus 2 plus b times of 1. By substituting or put x is equal to minus 2, so we'll get 3 times of minus 2 minus 1 is equal to a times of minus 2 plus 2 0 plus b. So we'll get minus 6 minus 1 is negative 7 is equal to b, or b is equal to negative 7. And now let us substitute or put x is equal to, put x is equal to 0, which implies 3 times of 0 minus 1 is negative 1 is equal to a times of 0 plus 2 is 2 plus b times of 1. So we can write minus 1 is equal to 2a, value of b is negative 7. So 2a is equal to 7 minus 1, 6. So a is equal to 3. So integral 3x minus 1 upon x plus 2 whole square dx is equal to a, that is 3 upon x plus 2 dx, and the value of b is minus 7. So minus 7 integral 1 upon x plus 2 whole square dx. So we can write 3 upon x plus 2, that is 3 times log mod of x plus 2 minus 7 times of integration of x plus 2 whole square is x plus 2 whole to the power of minus 2 plus 1 upon minus 2 plus 1 into 1 upon the coefficient of x is 1 plus c, or we can write 3 log mod of x plus 2 minus 7 upon minus 2 plus 1 is negative 1, so plus 7 x plus 2 whole to the power minus 1 plus c, or we can write 3 log mod of x plus 2 plus 7 upon x plus 2 plus c is the answer. Integrate the rational function 1 upon x power 4 minus 1. Clearly we can say that it is a proper fraction. Degree of numerator is smaller than the degree of denominator. And we can also write 1 upon x power 4 minus 1 as 1 upon x square whole square minus 1 square, that is x square plus 1 into x square minus 1, or is equal to 1 upon x square plus 1 into x plus 1 into x minus 1. We can resolve into partial fractions as 1 upon x plus 1 into x minus 1 into x square plus 1 is equal to a upon x plus 1 plus b upon x minus 1 plus c upon or cx plus d upon x square plus 1. X square plus 1 is an irreducible factor, so we can write x square plus 1, the numerator cx plus d. Now we can also write 1 is equal to a times of x minus 1 into x square plus 1 plus b times of x plus 1 into x square plus 1 plus cx plus d times of x plus 1 into x minus 1. Now if I substitute or put x is equal to 1, so 1 is equal to, so here we can say that since x is equal to 1, x minus 1 is a factor, so a times of 0, and here we can add b times of 1 plus 1, 2 times of 1 square plus 1, that is 2, and here again x plus 1 is a factor, x minus 1 is a factor, so we can take this is also 0, cx plus d times of 0. So which implies that a times of 0 is 0 and b times of 2 into 2, that is 4b, is equal to 1, or b is equal to 1 upon 4. Now substitute, put x is equal to minus 1. So we can write 1 is equal to a times of minus 1, that is negative 2, and minus 1 whole square is 1, 1 plus 1, that is 2, and here it is, since x is equal to minus 1, so x plus 1 is a factor, and here also x plus 1 is a factor, so the remaining 2r will be 0. So we can write negative 4a is equal to 1, which implies a is equal to minus 1 upon 4. Now let us substitute or put x is equal to 0. So we have 1 is equal to a times of minus 1, and 0 plus 1 is 1, plus b times of 1 and again 1, plus c into 0, that is 0 plus d times of 1 into minus 1. So we can write negative a plus b negative d is equal to 1, and we know the values of a and b. So we can write negative of negative plus 1 by 4, and again here plus 1 by 4 minus d is equal to 1, or negative d is equal to 1 minus half. So 1 minus half is half, so d is equal to minus 1 by 2. And now let us substitute or put x is equal to, or compare the coefficient of x power 3, comparing coefficients of x power 3. So the left side there is no x power 3 coefficient, so we can take 0 is equal to, and here it is 1x and x square, so it will be a times x power 3 single term, and again here x times of x square x power 3, so plus b times, and here we can write x into x cx, so we'll be getting cx cube, we'll be getting c, and there are no other terms we can find, so a plus b plus c is equal to 0. So which implies a value is 1 minus 1 by 4 and b value is plus 1 by 4 and plus c is equal to 0. So we are getting c is equal to 0. So we have values a is equal to minus 1 by 4, b is equal to plus 1 by 4, c is equal to 0, and d is equal to minus 1 by 2. And we can write here 1 upon x plus 1 into x minus 1 into x square plus 1 is equal to a upon, that is x plus 1, plus b upon x minus 1 plus cx plus d upon x square plus 1. So we can write integral 1 upon x plus 1 into x minus 1 into x square plus 1 is nothing but x power 4 minus 1 dx is equal to a value is minus 1 by 4 integral 1 upon x plus 1 dx, and plus b value is plus 1 by 4 integral 1 upon x minus 1 dx, and integral c value is 0, so 0 into x 0 plus d value is minus 1 by 2 upon x square plus 1 dx. So we can write minus 1 by 4 log mod of x plus 1 and plus 1 by 4 log mod of x minus 1, and again minus 1 by 2 integration of 1 upon x square plus 1 is tan inverse of x plus c. So this can also be written 1 upon 4 log a minus log b is log a by b. So we can write log x minus 1 upon x plus 1 minus 1 by 2 times tan inverse of x plus c is the answer. Integrate the rational function 1 upon x times of x power n plus 1. So which is a proper fraction. And let us solve this 1 upon x times of x power n plus 1 dx. Put x power n is equal to t, so that n into x to the power of n minus 1 dx is equal to dt. That is n times of x power n upon x dx is equal to dt. Or we can also write 1 upon x dx is equal to 1 upon n into x to the power of n dt, and we know that x power n is equal to t, so we can substitute x power n as t here. So 1 upon x dx is equal to 1 by nt dt. So our integral we can write 1 upon x dx is dt upon nt into x power n plus 1, that is t plus 1, which is equal to 1 upon n integral 1 by t into t plus 1 dt. And we have the property 1 upon x into x plus 1 is equal to 1 by x minus 1 by x plus 1. So here you can write 1 upon integral 1 by t minus 1 by t plus 1 dt, which is equal to 1 upon integration of 1 upon t is log mod t minus integral 1 upon t plus 1 is log mod of t plus 1 plus c. So we can write 1 upon n log mod of t divided by t plus 1 plus c, that is 1 upon n log, and t value is x power n, so we can write log of x power n divided by x power n plus 1 plus c is the answer. Integrate the rational function cos x upon 1 minus sin x into 2 minus sin x. So we can write integral cos x upon 1 minus sin x into 2 minus sin x dx. Let us substitute. Put sin x is equal to t. So on differentiating we have cos x dx is equal to dt. So integral cos x dx is dt upon 1 minus t into 2 minus t. So we can see that 1 upon 1 minus t into 2 minus t is a proper fraction. So we can resolve into partial fractions as a upon 1 minus t plus b upon 2 minus t. So we can add 1 is equal to a times of 2 minus t plus b times of 1 minus t. To get the constants, let us substitute. Put t is equal to 1. So we'll get 1 is equal to a times of 2 minus 1, that is 1, plus b times of 0. So we got a is equal to 1. And now put t is equal to 2. So we get 1 is equal to a times of 0 plus b times of 2 minus 1 minus 2 is negative 1. So we have b is equal to negative 1. So here we can write integral a upon, that is 1 upon 1 minus t dt minus b value is negative 1. So minus 1 upon 2 minus t dt. And integration of 1 upon 1 minus t is log mod of 1 minus t divided by coefficient of t is minus 1. So we can write minus, and again minus log mod of 2 minus t divided with again coefficient of t is negative 1. So we can write minus 1 plus c, or we can also write minus, we can take minus, or here it will come plus. So minus of minus, so we can write here log mod of 2 minus t minus log mod of 1 minus t plus c, or log a minus log b, we can write log a by b. So 2 minus t upon 1 minus t plus c, or we can substitute t is equal to sin x. So we can write log mod of 2 minus sin x upon 1 minus sin x plus c is the answer. Integrate the rational function x square plus 1 of x square plus 2 upon x square plus 3 into x square plus 4. Here we can see that the degree of numerator is 4 and degree of denominator is also 4. We can say this is improper fraction. So let us simplify this. Let y is equal to x square, so that we can write y plus 1 into y plus 2 upon y plus 3 into y plus 4. Since it is an improper fraction, we need to go with the division. So y plus 1 into y plus 2, that is y square plus 2y plus 1y, that is 3y plus 2 upon y square plus 3y plus 4y, that is 7y plus 12. Let's go with the division. Y square plus 3y plus 2 divided with y square plus 7y plus 12. So 1 times we'll get y square plus 7y plus 12. So subtraction, you will get 3y minus 7y is minus 4y and 2 minus 12 is minus 10. So we can write this expression as 1 plus minus 4y minus 10 upon y square plus 7y plus 12. That is 1 plus minus 4y minus 10 upon y square plus 7y plus 12 can be taken as y plus 3 into y plus 4, or we can write 1 minus 4y plus 10 upon y plus 3 into y plus 4. And here we can say that the degree of numerator is 1 and degree of denominator is 2, so it is a proper fraction. We can resolve into partial fractions. So our expression is 1 minus 4y plus 10 upon y plus 3 into y plus 4. So the partial fractions of this 4y plus 10 upon y plus 3 into y plus 4, we can write it as a upon y plus 3 plus b upon y plus 4. So we can write 4y plus 10 is equal to a times of y plus 4 plus b times of y plus 3. Now put y is equal to minus 4. We get 4 into minus 4 minus 16 plus 10, that is negative 6 is equal to a times of 0 plus b times of negative 4 plus 3 is negative 1. So minus b is equal to minus 6, so b is equal to 6. And y is equal to minus 3, which implies 4 into minus 3 minus 12 plus 10, that is minus 2 is equal to a times of minus 3 plus 4 is 1 plus b times of minus 3 plus 3 is 0. So we have a is equal to negative 2. So we can write integral 1 minus 4y plus 10 upon, or let me substitute y value. So we can write here integral x square plus 1 into x square plus 2 upon x square plus 3 into x square plus 4. We can write it as 1 minus 4 times of x square plus 10 upon x square plus 3 into x square plus 4 dx, which can also be written as integral 1 dx minus, and the partial fractions we can write here a upon, that is 2 negative 2 upon y plus 3, that is x square plus 3, and again plus b times of, that is b is 6 times of x square plus 4 dx. Integration of 1 dx is x minus minus of minus, here we can write plus, so this is also minus, so plus 2 times of integration of 1 upon x square plus 3 is 1 by root 3 tan inverse of x upon a, because x3 we can write root 3 whole square, and again minus 6 times of 1 by 2, because x square plus 4 we can write x square plus 2 square into tan inverse of x upon 2 plus c, that is x plus 2 upon root 3 tan inverse of x by root 3 minus 3 times of tan inverse of x upon 2 plus c is the answer. Integrate the rational function 2x upon x square plus 1 into x square plus 3 dx. Here we can go by substitution method. Put x square is equal to t, so that differentiating 2x into dx is equal to dt. So we can write the integral dt divided by t plus 1 into t plus 3. And here the difference between t plus 1 and t plus 3 is 2. So let us multiply and divide with 2. So 2 upon t plus 1 into t plus 3 dt, or we can write 1 by 2 times integral t plus 3 minus of t plus 1 divided by t plus 1 into t plus 3 dt. So which is equal to 1 upon 2 times integral 1 upon t plus 1 minus 1 upon t plus 3 dt, or 1 by 2 times integration of 1 upon t plus 1 is log mod of t plus 1 minus log mod of t plus 3 plus c, or we can write 1 by 2 log a minus log b is log a by b, so we can write plus c, or we can write 1 by 2 log, substituting back t is equal to x square, so we can write x square plus 1 upon x square plus 3 plus c is the answer. Integrate the rational function 1 upon x times of x power 4 minus 1 dx. Let us solve this problem by substitution method. Put x power 4 is equal to t, so we can write 4 into x power 3 dx is equal to dt, or we can write 4 into x power 4 divided by x dx is equal to dt, or we can write 4 t upon x dx is equal to dt, or we can also write 1 upon x dx is equal to 1 by 4t dt, so that we can write the integral 1 upon x dx, 1 upon x dx is 1 by 4t dt, so 1 upon 4t dt and divided by t minus 1. 1 by 4 times integral 1 by t into t minus 1. Since the difference between t and t minus 1 is 1, so we can write t minus of t minus 1 dt. So which is equal to 1 by 4 times integral t upon t into t minus 1 minus t minus 1 upon t into t minus 1 dt. That is 1 by 4 times integral 1 by t minus 1 minus 1 upon t dt. 1 upon 4 integration of 1 upon t minus 1 is log mod of t minus 1 minus log mod t plus c, or we can also write 1 by 4 times log a minus log b is log a by b plus c, that is 1 by 4 log. Let us substitute t value. T value is x power 4, so we can write x power 4 minus 1 upon x power 4 plus c. Integrate the rational function 1 upon e power x minus 1 dx, which is equal to, or let us solve this by substitution method. Put e power x is equal to t, so we can write e power x into dx is equal to dt, or dx is equal to 1 upon e power x, that is t dt. So our integral can be taken as dx is 1 upon t dt divided by e power x minus 1, that is t minus 1, which is equal to, the difference between t and t minus 1 is 1. So we can write t minus of t minus 1 divided by t into t minus 1 dt. Simplifying, we can write integral 1 upon t minus 1 dt minus t minus 1 upon, that is 1 upon t dt, which is equal to log mod of t minus 1 minus log mod of t plus c, or we can write log mod of t minus 1 upon t plus c. Let us substitute it back. T is equal to e power x, so e power x minus 1 upon e power x plus c is the answer. Choose the correct answer. Integral x upon x minus 1 into x minus 2 dx is equal to. Here we can say that the degree of numerator is smaller than the degree of denominator, so it is a proper fraction. So we can resolve into partial fractions. We can write x upon x minus 1 into x minus 2 is equal to a upon x minus 1 plus b upon x minus 2. So that x is equal to a times of x minus 2 plus b times of x minus 1. Now let us substitute or put x is equal to 1. So we get 1 is equal to a times of 1 minus 2, that is negative 1. So a is equal to minus 1, and by substituting x is equal to 2, so we get 2 is equal to a times of 0 plus b times of 2 minus 1, that is 1. So b is equal to 2. So we can write x upon x minus 1 into x minus 2 is equal to minus 1 upon x minus 1 plus 2 upon x minus 2. So integral x upon x minus 1 into x minus 2 dx is equal to minus 1 times 1 upon x minus 1 dx plus 2 times of integral 1 upon x minus 2 dx, which is equal to minus log mod of x minus 1 plus 2 times of log mod of x minus 2 plus c, which is equal to negative log mod of x minus 1 plus log mod of x minus 2 whole square plus c, which is equal to log x minus 2 whole square divided by x minus 1 plus c. So the answer is log mod of x minus 2 whole square upon x minus 1 plus c is the answer. Integral 1 upon x times of x square plus 1 dx. So we can see that the numerator degree is 0 and denominator degree is 3, which is a proper fraction. So we can write 1 upon x times of x square plus 1 can be written as a upon x plus bx plus c upon x square plus 1. Since x square plus 1 is an irreducible second degree polynomial, so we can write bx plus c in the numerator. And so 1 is equal to a times of x square plus 1 plus bx plus c times of x. So let us substitute or put x is equal to 0. So we get 1 is equal to a times of 1 plus 0. So value of a is 1, and by substituting x is equal to 1 or comparing the coefficient of x square, comparing coefficient of x square, so we have 0 on the left side, and here we can write a and bx square. So b, a plus b is equal to 0, or b is equal to negative a, so minus 1. So the value of b is negative 1 and the value of a is positive 1. And now let us substitute or put x is equal to, or comparing coefficients of constant. So we have the constant on the left side is 1, on the right side we can see a into 1 a, and here bx square plus cx there is no constant. So already we got a is equal to 1. So let us not go with coefficient of constant. Let's find the coefficient of x. So here the coefficient of x on the left side is 0, and here the coefficient of x we can write c into x, only c. So bx square plus cx, so c is equal to 0. We got c value 0. So our integral we can write integration 1 upon x into x square plus 1 dx is equal to a value is 1. So 1 upon x dx plus bx value, b is equal to negative 1, negative x upon x square plus 1 dx. And in the second integral we can substitute x square plus 1 is equal to t. So 2x dx is equal to dt, or x dx is equal to 1 upon 2 dt. So we can write 1 upon x dx is log x, and here minus x dx is equal to 1 by 2 dt divided by t, that is log mod x minus 1 by 2 log mod t plus c, or we can write log mod x minus 1 by 2 log t value is nothing but x square plus 1 plus c. So we can go with an option log mod x minus 1 by 2 log of mod x square plus 1 plus c, which is option A.